but the LMI was set for the previous load, and it didn't give any indication for what would happen if the boom was extended out 115 feet and elevated above horizontal. And so I'd sat down with the crane operator and went over the load charts with him, and basically beyond 60 feet, that boom is going to be unstable, which it was, with the outriggers in. But there was lots of other things that was going on in that project at the time. So the contractor had been there less than a year. It was a Department of Energy project, and they did not have an approved hoisting and rigging manual. They didn't have any of the procedures that were up to date for that particular project. And there had been some previous problems with heavy equipment on that site, and one of the corrective actions for that was that the keys to any heavy equipment needed to be in a locked cabinet that only the supervisor had control of. And the project had not implemented that. So it turns out that this problem was much deeper. And this crane operator was the best crane operator that they had. And the other crane operator who was there, who's kind of acting in a spotter capacity, hadn't been briefed, and he was pretty experienced as well. And so they didn't, there just was a lot going on. So what would you do to fix this system that led to this event? How would you make it more error tolerant so that a crane operator is going to be less likely to extend a boom with the outriggers back in? So take a couple of seconds and think about that. Now, what I normally do is when I do this in a group, we write down what solutions you came up with, and typically when you're fixing the operator, you're looking at disciplining the operator, which in fact they did. This particular project, before I got there, it sent the crane operator, the other crane operator, and the foreman off for 2 weeks of unpaid vacation, and they disciplined them. And they thought, well, that'll get people's attention. So when we came back and we looked at all the things that was going on, we found that there was so much churn going on in the project that from a leadership perspective, the leaders actually didn't know what was going on in terms of the work, nor did they understand the deficiencies that they had in their operating procedures and how that was carried out to their workforce. So they ended up learning a lot, but unfortunately the damage had been done in terms of trust and confidence in their workforce, because the first thing that leadership had done was to blame and punish their workers. And all too often in industry, when bad things happen, we look to the person who touched it last as the person to blame. So I understand that many of you looked at you responded to the poll saying, well, we want to learn and improve. And the reality is that in most industries, they really want to blame and punish, which is going to be the focus of what we do. So next slide, please. So the first law of safety in my book is never take a sleeping pill and a laxative at the same time in any order. And so I had a colleague was presenting this concept to an ASSE convention, and an engineer raised his hand and he says, does order make any difference? And he thought about it and he went, well, no, not really. So for any engineers out there, the order is non-specific. So the next slide is the next corollary, which is to never remove a safety barrier that has a dent in it. And that's actually a fairly famous axiom in traffic safety. So we want to make sure that in the area of safety and in investigations that we try to learn, we try to improve, and that we do no harm. So next slide is our agenda. So the first thing we're going to be doing is looking at a review of what we covered last year, just as a brief refresher. We'll get into learning teams, what they are, and the phases of learning teams. I'll give you some case studies at the end, and then some thoughts on getting to Foresight. So next slide. So one of the things that is my focus is to look at errors without consequence. So if you've got systems that are error tolerant, irrespective of where that was a mistake or was a violation, if the system can tolerate that error, that shows that they're safe and that those defenses that you've got are working. Next slide. So what I would tell you is that safety is not the absence of accidents. And there's a lot of discussions across the industry about getting to zero, and zero is not measurable. So what I would tell you is that safety is actually the capacity of defenses to fail gracefully. So if something bad happens, have you thought it through, and do you have the resilience to recover gracefully? And so that's what that's all about. So next slide. It discusses the principles of HPI, and there's 5. And the first is that people are going to make mistakes. And what's interesting is that your best people can sometimes make the worst mistakes. The second principle is that error-likely situations are predictable, manageable, and preventable. So that means that if you have constructed procedures, or you have constructed signs, or you have conditions that would lead to error-likely situations, you can actually see those and you can do something about it. Thirdly, people's behavior is influenced by the organizational processes and values. So what leaders reward, what leaders pay attention to, how you construct your reward systems, how you construct your procedures and what have you is going to guide individual behavior. And then fourthly, people are going to do well because they've been encouraged and reinforced by their leaders, their peers, their subordinates, and even the work itself can serve as a reward to lead to high performance. And then finally, the last principle, which is what we're all about today, is that events can be avoided by an understanding of the reasons why mistakes occur and the applications of lessons to be learned from those past events or errors. So how do you learn? Okay, next slide. And this discusses human performance in a nutshell. And you know, the statement is that the purpose of human performance is to reduce the frequency and severity of accidents or events that are triggered by human error. So let's think about this a couple of minutes. If you look at frequency and severity of events or accidents or a business event or what have you, frequency times severity in my world of engineering is an equation for risk. So what we're trying to do is to reduce risk for these events that end up triggered by human error, and that word trigger is important. So the view you've got to think about is that accident was waiting to happen. It was waiting for the human to touch it. And so in our world, when we look for the person who touched it last to blame and punish, that's going to be a recipe for disaster. So that's what we're all about, is we're reducing risk for those events that are triggered by human error. So let's look at how we see events with the old view and the new view in the next slide. And the old view, which is kind of where most organizations are, is that human error is a cause of accidents. So when you think about an airplane accident, the first thing you hear about on the news is that it was due to pilot error, and that was the root cause. We just had a recent event with British Airways where they lost the server, and the CEO for British Airways said that the root cause was because of a power supply that blew. Well, they were 4 days into this event before they started getting back to normal. Well, I can assure you that a power supply is not the root cause. And British Airways is not a very resilient airline if a single power supply can trigger a global event that has lost them conservatively 100 million pounds. But you'll see this in the old view, is that human error is the cause of accidents, and thus, to explain failure, your investigations have got to seek failures in various parts of the system, which also includes inaccurate assessment by humans and bad decisions. And so Sidney Dekker, who's one of our mentors in the field of human performance, says that in the new view, human error. And so if you want to explain failure, don't try to find out where people went wrong. Instead, find out how what they did, how it made sense to them at the time. Okay. So that's the old view. The next slide are people are working where it's clearly safe and clearly people are somewhere in that gray area where it's uncertain, and so people are going to discover that. So next slide. So the traditional emphasis on pre-work and planning is that if we do good pre-job briefs, if we do work planning, if we do our JHAs or JSAs, we have good training, that will reduce the line work as a match. So hit it again, Jonah. But we're only looking at what occurs before the job starts. We're not looking at what happens when the job is in progress, and we're not looking at what happens if something goes wrong. And so with British, they didn't think through, so they had a failure of forethought of when something bad happens at the worst possible time, they never consume. This traditional safety emphasis is okay, but it only uses a failure sequence of moderate. When you're looking at safety investigations, and it's difficult, and so we want to go back to this Newtonian view of a simple cause and effect, which obeys the laws of physics. And we think about Newtonian, and you go back to Newton's force equals mass times acceleration is first law. Second law would be a body in motion tends to stay in motion, and a body at rest tends to stay at rest. And then the third law, which is for every action, there's an equal and opposite reaction. And it's the third law that drives our thinking on failure, and that's the notion of cause and effect. And what I would tell you is that it only applies in the physical world. It does not apply in the cognitive world. So in that 6-inch space between your ears of gray matter, stuff going on in there physics, and so it doesn't. And so that's on to the next slide. Excuse me. And so So Jonah, we're going to click through this, and I can't see this in front of me, so I'm flying blind.
Okay.
But
yeah, I got the whole thing.
Yeah, so at the, let me pull it up in slideshow mode. So, so if you click it once, you've got this black line at the top that says start of the job.
Yep.
And what that defines is work as planned or work as imagined. So the black line is management's line. Click it again, and the next line is the blue line, and that's the work is done. And this is very important. So workers go out, they've got a pre-job brief, they've got a procedure, they've got training, they've got, whatever you give them. And they've got to go out and figure it out and get the job done. And they're only going to work as safely as they think they need to be in order to get that job done. And so that line that's going all over everywhere represents a multidimensional line of how workers figure stuff out. So you click it again, and that normally leads to success. So so click it again, that goes away, and so you click it again, now you've got an event. And we look at our event in the context of the difference between the blue line and the black line. Now the black line is purely imaginary. It's the work is imagined. And it only exists in the minds of managers and maybe foremen, work planners, safety professionals, what have you. And then they look at the blue line and they go, oh, they were willfully and knowingly violating our procedures. And so you hear that a lot. So go ahead and click it again, make that go away, click it one more time. And so now you've got a dotted red line that represents hazards building up in your project. And those hazards could be height, it could be weight, it could be chemicals, it could be pressures, it could be temperatures, but they're things that build up in your project that you don't necessarily see. So for example, when you're doing a construction project, if you're building it up multi-stories, it's getting higher and higher, and so one of the hazards that's building up is gravity. And so if a worker drops a tool off of a ladder that's on the first floor, it's probably not going to hurt anybody, and a hard hat is sufficient. But if that tool is 80 feet up in the air and it hits your hard hat, that hard hat probably will not cushion the blow. So hazards are going to be building up in your project that you can't normally see, and where that hazard builds up and it intersects the actual work practice. And go ahead and hit that one more time, Jonah. The event happens, and that obeys the laws of physics. So hit it one more time. You see that gap between work is done and work is as imagined, and then one more time, and that's, so what we're looking for is the context of that event, which is where we learn. What's the actual gap between the blue line, which represents work is done, where the workers are, and the actual hazards. So, and what I would tell you is when you look at this, and I ask the question, so do you want to be on the right side of that curve, or do you want to be on the left side? Everybody goes, well, the left side. And that's right. And you want to be there because that's error tolerant. So if you've got an error on the left side of that graph, probably not much bad is going to happen. But if you're all the way over to the right, you are a single error away from a consequence you can't stand. And it's natural when you're all the way to the right to blame the person who touched it last. But you as investigators have got to figure out, okay, what did we do to get to that point where that gap between work is imagined and work is done was so great, and how did we not recognize the hazards that built up? So that's our task in the learning teams, and we're going to learn more about that in a few minutes. So next slide, what I tell you is the pressure to know outweighs the pressure to learn. And so as managers, when something bad happens, you want to learn, you want to figure out, okay, what happened, and you're pressured to fix. And so when I go out and I ask managers, do why do you do these investigations in the first place? One of the answers I get, which is a common answer, is so that this event never happens again. And what I would tell you is that when I look at the gap between work is done and the work is imagined, and then the buildup of hazards, and there's a unique combination of variables that came together at that moment in time to create that circumstance of that we call an event or an accident. And I tell these managers with some assurance that if you do nothing, that accident will never happen again that way. And so we're always trying to fix the accident that just happened, but it's due to a normal combination of variables that just kind of came together on that day. So you can't fix that, but you can fix the conditions that led up to that, and you'll never learn that if you don't ask those questions. So that's what we're all about today, is how do we maximize learning? So next slide, we're going to go to learning teams. And so before we do that, I want to start the next thought exercise. So I want you to think about this. So hopefully you're on the next one, Jonah. A bat and a ball costs $1.10, and the bat costs $1 more than the ball. So very quickly, how much does the ball cost? Okay, did you come up with 10 cents? And if you did, that's close, but you're wrong. So try this. If y is the price of the ball and x is the price of the bat, and x plus y equals $1.10, and y plus $1 equals x, and then that parenthetically y plus $1 plus y equals $1.10, so 2y equals 10 cents. So y equals 5 cents. And so Daniel Kahneman, who wrote the book Thinking Fast and Thinking Slow, illustrates this example, the first thing in his book, to show the difference between fast thinking and slow thinking. So 10 cents is the result of fast thinking, and it's quick, it's easy, and it's sometimes wrong, but it's based on this fancy word called heuristics, which is a mental model. So over time, you build up these mental models that tells you for sure that the answer to that question is 10 cents when really it's 5 cents. So learning teams start off, they try to stay in slow thinking mode most of the time, and that's important. So let's move on. So so let's talk about the phases of learning teams, and this comes from Todd Coughlin's book, Pre-Accident Investigations, Better Questions. And it's a poorly edited book, but the concepts are good, and Todd and I are good friends, and we've used this method many, many times. So the first thing you do is you determine the need for a learning team. Then you have your first session where you stay in learning mode only, and then you provide some soak time in between the first session and the second session so that people can think about what they've done. So in the second session, you start learning mode, and then you get to, what are your current defenses? You micro-experiment to build new ones. Then sixthly, you track actions for criterion and closure. And then finally, you communicate to others what you've learned. And one of the best companies that does this is Toyota. So when you think about the Toyota way, that's where this comes from. So next slide. So let's start about thinking about, when would you need a learning team? And the reality is anytime you've got variables that you don't understand, that's a good time to do a learning team. But some have more information than others. And so you look for context, and what I would tell you is to start with events that cause actual harm. And then the next priority might be your near hits. Some people call them near misses, but they're really, to me, words are important, and they're near hits. And the reality is you don't have enough time or money to investigate everything. So if you do try to investigate everything, you'll go crazy or broke. So don't do it. Second, Next slide. So you go to the first session. So you get your team together, and so who should be on the team? Well, the people who really ought to be on the team are the people who were there, the people who do the work. So this is not a team of managers. This is not a team of supervisors. This is not a team of engineers. This is a team of people who understand the work, and preferably who were there. So explain the process to them. This is, have about 30 minutes of training. Set your goals and expectations. This would be where the responsible manager comes in and says, hey, I've gathered you together. This is important to me. It should be important to you. And I want to learn everything I can from this event, and you're the guys to do it. Okay, so that responsible manager should do that. Do some instruction on new view versus old view, and then start them out by telling them that you don't want to have any solutions today. And every one of those people who came in on the learning team came in with a solution in mind, and they want to talk about it, but that's not the time. When you're going through the learning team, one of the things that you need to do is to change the way you ask questions. So I would tell you to ask how questions and not why questions. And how questions are, it's a psychological thing. They are less threatening than asking why questions, because if you ask why questions, especially of men, it tends to question their motive. So you'd be surprised at how much better questions you get with how. So when I start off with learning teams, the first thing I ask them to do, and there's 2 products of the first day, and that's to have them describe how work gets done normally. How do you start the day when you come into work? What do you do for a crew brief? How do jobs get assigned? What happens when you run into problems? All those things. So the normal thing about work. Something else I would encourage you to do, and I've gone back and forth with Todd Conklin on this, is that the person who comes in to coach the learning team doesn't need to know anything about that event. In fact, it's better that they don't. And so when I've come in absolutely cold, I've read nothing, I know nothing, it helps me ask better questions. And so whoever's kind of coaching this team, yeah, I would tell you it's better that they really don't know anything about it. And the less you know, the better, so you can ask better questions. So the first thing you start thinking about is how does work get done normally, and then have them write down all the conditions that needed to exist at the time for this event to take place. And what you find is a whole lot of stuff needed to be in place for this event to happen. All right, so next slide. So provide some soak time, preferably overnight. And it's okay for them to go out and look at some more stuff, get some more information, but they want to let this soak in, preferably while they're sleeping. And it's now is the time to add additional members. So the last team I was on, we added a work planning manager who actually had something to contribute to the team. Sometimes you might want to bring in an engineer, whatever you need. Next slide. So the second session, you start in the learning mode, you recap what you did the day before, but you're going to find that it's inadequate to capture what you thought you had captured. So you do some more, and then that's where you transition from learning to action, and you begin to define your solutions. So this is where the reward comes in play. So next slide, you're going to start with what were you relying on to work, and how effective were they? A lot of times the defenses that you think you had were never challenged. We had I was working for a company where they came in and replaced another contractor who didn't have much, world-renowned procedures, that were very didn't read them or use them. And they continued to fuss about the procedures and getting people to follow them. Well, HR came in and they found that the operators were functional providing detailed procedures to people who don't read is not necessarily a good thing. In fact, it kind of upset the operators by giving them all these procedures that they couldn't read. So that defense of a written procedure was actually never challenged because it was never read. So you've got to look at that. And then, so you look at how effective your defenses were. Some are good, some are bad. You want to make sure that you don't throw away the good ones. And then you look, the classic example of this was a perfume factory that was shipping out high-end perfume, and one time they shipped a box that didn't have any in it, and they got lame, they lost the customer, and it was really bad. So managed that it cost $1 million to radiograph every box. And that would conclusively make sure that they always ship product on the line leading to shipping. Seeker overheard what they were talking about for this proposed project, and he came over to the manager and he said, well, we've already fixed it. And it turned out what they had done was they put a large fan on the assembly line, and if an empty box came by, it just blew the empty box off the line, and they never shipped another empty box. So in this particular case, workers micro-experimented with solutions, and management didn't know about it. So we do want to micro-experiment and to see if these solutions actually work. All too often when we get in the solution mode, we come up with what we think is a good solution, we dust off our hands, we go, okay, that'll work. And we never go back to see if it actually did. So micro-experimentation is a good thing to do. All right, next slide. Excuse me. So we want to track these things for closure, and the solutions have got to be mutually agreed on by the team and the managers. So this is where the resource manager comes back into play, because the resource manager has got the resources to actually fix it. And then they've got to figure out, is it important enough to spend money on? Do we want to do it right now or later? So often we get the management questions of, how come if these solutions were so simple that they didn't fix it earlier? And there's really three reasons. Many times the operators or the workers feel it's not my job to fix it. Sometimes they go, if I fix it, I'll get in trouble. And then thirdly, they may say, I just don't have the authority to fix it. So what we want to do is we want to give the workers, we want to take all those excuses away and give them the authority and the capacity to go ahead and fix stuff. And what I would tell you is the more you trust your workers to come up with solutions, the more solutions and better solutions they're going to come up with. Okay. So next slide. We're going to communicate to others. So if you've got this great learning team, but you don't tell anybody about it, nobody knows. And so what this does is it gives workers the confidence that they're going to need to work safely after an upsite. So if you've had a bad accident, somebody got badly injured, or as we say in the South where I'm from, killed or worse, workers are going to be hesitant to go back to work. So the learning team gives them the confidence to work safely. Additionally, the learning teams give the company the capacity to work more safely. And the capacity is in the additional or better or more resilient defenses that they discover. Okay. So once you figured that out, the company's final step is to look at, what's the extent of this condition? Does it apply someplace else? And the extent of the cost. So whatever, management, systems ended up setting this thing up for failure, do those causal conditions exist someplace else? And then if you're seeing a broad extent of cause, the company leaders need to ask themselves the question, what's the cause of all this extent? Which is a very perceptive question. And if they're truthful, they'll find out that the cause of that extent is them. It's whatever they're doing from a leadership perspective, because whatever they're doing is what led to this. And I, as a leader, when I was chief engineer of an aircraft carrier, and bad things would happen, and they did, I would ask myself out loud, what did I do to encourage, allow, or enable this to happen in the first place? And by doing that and doing it regularly, it encouraged the leaders that worked for me and the sailors to question themselves. Okay, so those are all good questions to ask. All right, next slide. So just to recap, the phases of the learning team is, first you got to figure out that you need one, then you bring together a learning team, and you bring them together in the first session in learning mode only. Then you soak for about a day, preferably overnight. You come back, you start learning mode, and then you get to solutions, starting with your current defenses, and then what can you do differently to add capacity and confidence to your workforce. Track your actions to closure, and then communicate. And by doing that, you're going to end up with more and better learning teams as you go along. The first one you're going to think is terrible. And I will tell you that every learning team that I have ever done, I've done a bunch, could always be done better. And that's kind of how you got to look at it. So I'm going to give you some examples in the next slide. And I'll go through these briefly. Several years ago, about 15 years ago, in Augusta, Georgia, there was an Amoco polymer, especially polymer plant that made stuff for their customers. And one night at 2 o'clock in the morning, 3 maintenance mechanics were working on a knockout tank that had been taken down for maintenance, and they were removing the cover off of it. And all their indications to them told them that it was depressurized. Well, in fact, there was 800 psi of pressure on that tank, and when they got the last bolt off, it exploded, and it killed all 3 of them. And it was bad, and my company at the time got involved in the lessons to be learned from it. But a year later, Amoco sold it to Solvay, which is a chemical company out of Belgium, and they came in, and I happen to know the plant manager whose son ran cross country with my son, and I started talking to him, and one of the things that they did was they did these teams that, it was different then, but I would call it a learning team, and he eventually got up to 100 of these learning teams a year. And in less than 2 years, that company turned around, and it became profitable, and it became incredibly safe, and their injury rate went to practically 0. And I talked to the plant manager, who is a chemical engineer, and he's your typical introverted analytical chemical engineer, but he actually knew his limits, and he said, it has nothing to do with me. But it has to do with these learning teams that I commissioned, and now I can't stop. And so he has a workforce of 120 employees that's doing 100 learning teams a year. And you'd think if they're doing these learning teams, when do they have time to work? And the reality is every time they see some sort of a variance, the workers themselves stop what they're doing, they huddle, they do a learning team, they figure out what's going wrong, and then they come up with solutions, and then they notify management, hey, here's what you need to be doing. And now they can't stop it. So so that's one area where the company had come from, they were dirty, they were filthy, they had waste products everywhere, they were in trouble with OSHA, and then they killed 3 people, to a very profitable company. So that's one. I was at the Paducah gaseous diffusion plant, and I've talked to the safety people there, and I'm allowed to talk about this. I helped them with a learning team several months ago where they had an industrial hygiene event. And the company had already decided to discipline, everybody involved. But we did this learning team, and I won't go into the details of it, but we had the two IH techs, we had a safety lead, we had a couple of welders that was involved in this event, and the weld foreman and the work planner huddled in this learning team for a couple of days. And when they outbriefed it to management, the first thing they asked me was, what was I going to tell management? And I said, I'm not going to tell management anything. You're going to elect a spokesperson to speak for you. And they didn't want to do it, but I made them. And so they elected two people, a welding foreman and the safety lead. And so they're briefing this to a couple of directors, and they had all the answers. They had way more answers than I did. And you could see their confidence and their pride building up as they were briefing the management team. So what I would tell you is that just the act of asking workers questions and then doing something about what they tell you adds a lot in terms of worker confidence. And then in terms of the capacity of the company to move forward safely, the ideas that the workers give to management are always better, and they're not necessarily more expensive. So think about that. So the third example was Savannah River Nuclear Solutions. We had a pretty significant, and this was my last company that I worked for. We had a pretty significant radiological event where a worker poked himself in the finger with a wire that was contaminated with plutonium-238, which you don't ever want to get in you. In the initial investigation, it said with some assurance that the worker had willfully and knowingly violated his training and his procedures and injected himself with plutonium. Now, they did that because they felt they had no other choice. And the reality is that if they can demonstrate that the worker did this willfully and knowingly in violation of their procedures, that it absolves the company of liability. Well, OSHA doesn't look at it that way, just saying. So when we got in and we approached it with learning, we discovered that this particular worker was the best worker they had, and he had adapted his method for whatever this task was, as had every other worker on his shift, because we asked them what their method was, and we got 6 different methods. And his was the best, and it was acknowledged by the other workers that it was the best until it wasn't. And it turned out that we had all sorts of issues between radiological control, engineering, projects, the environmental folks, and the stuff where we shipped the waste to New Mexico to WIP. It turned out to be really complicated, and the solutions ended up being complicated. But we had to come up with something that was A, not going to blame people, but B, was going to provide something effective. And that project ultimately ended up doing okay. So we did better. Did a learning team for a major oil company a couple of years ago, and we looked at, it turned out that for this oil company, they'd had a fatality, and they had some pipeline events that were near fatalities. And as we looked into it, and it was very involved, it was all over the country, we discovered that one of the things that led to this was that the company had abandoned configuration management of their drawings. And they'd done this many, many years ago as a cost-saving measure, but they didn't understand how hazards would build up in terms of equipment that was now no longer controlled out in the oil fields or out in the Gulf of Mexico or in refineries, and how that would ultimately build up to the point where workers, maintenance mechanics, were working on things that they didn't have any clue. So from these examples, you can, what we're looking for is we're looking for safer, we're looking for better, we're looking for more cost effective. And in the end, the way we keep score in any of our companies is with money. And so all of these companies ended up making more money, and they were safer, and they learned more, and they had more capacity, and they had more confidence to work safely. Now this hasn't made all the problems go away, but the prime mover of all this is money, and they're making more money. So this is not about safety. This is about working safer and more effectively so that you can earn more money. And I know that that's contrary to a lot of safety folks, but that's kind of how we do business in today's world. So let me move on. So this is getting to Foresight. And so I and a bunch of colleagues have looked at really successful companies in the construction industry and government contracting and what have you all over the country. And we see four things that they tend to do very well. The first is that they're really good at predicting the next failure. So one of the questions that I ask of management and of workers wherever I go is I ask them, where's the next accident going to take place? And the people who've got the biggest handle on the next accident are the workers and not management. And so when you then have managers asking workers that question, they now know where it's going to happen, and they can do something about it. So it's the workers on the shop floor or out on the construction project kind of understand where the next failure is going to take place, but they don't necessarily know how to communicate that unless management is open about asking those how questions and getting out in the field and listening to really bad answers. So these companies are good at predicting failure. They're good at reducing complexity at the worker end. When they get near hits, they respond with urgency and perhaps some emotion. But then when events happen, bad events happen and people get hurt, they respond very deliberately, and they're in the learn and improve mode, not in the blame and punishment mode. So they don't respond to an accident site yelling and screaming and taking charge and what have you. They'll respond to an accident site by, figuring out what's going on, getting the lay of the land, and moving on. So with that, I'll go to the next slide, which is if you have any questions, bring them up on the site. We've gone a little long, but we had some technical difficulties going off on this. But if you have any questions, get them in, and we'll be happy to answer them. And then the last slide, if you've got if you need more information on this, I'm going to be teaching an HPI and accident investigation classes the middle of October, the 17th through the 19th, up at ITI's headquarters in Woodland. And so I'm going to turn it back to Jonah, and I am totally offline with what's going on, so I have no control. I can't see anything.
Yeah, no, we can still hear you and everything, Bill, and thank you. I was following along with the slides best I could.
Great.
Again, everybody, apologies about the technical difficulties. We just talked about human performance for 1 hour. I'm going to blame the machines. How's that for some irony? But no, I switched out computers, and then there were no issues after that. So again, apologies. We can edit a lot of that out on the recording if you do want to review some stuff. I will make the presentation file available as well as the recording once it gets edited and cleaned up a little bit, likely later today, but I can send out notifications for that. Since we did go over, there are a couple questions, but we can handle those offline since we want to respect everybody's time and thank everybody for joining us today. Again, apologies for the rough start, but yeah, once we turn things over to Bill, Yeah, it was great. Great information. Again, the idea of changing the perspective to see things a little bit differently, and you touched on it, Bill, at the very end. The bottom line, yes, safety and processes and things are improved and more effective, but in terms of a business, when it's really affecting the bottom line, I guess that's really going to be a mover of things, as sad as that is in some cases, but it is the reality. So no, this is powerful stuff. Again, a bit another way to look at things in a non, I guess, linear or typical way that many of us are used to. So that kind of perspective and knowledge is great, and it applies not only to lifting, hoisting, rigging, crane work, but really any industry and any business. So thank you again for joining us. Thanks, everybody. With that, I think we're going to sign off, and then until next time, this has been the Showcase webinar series.